To our tractor, we've been requested to get to 1,100 gallons a minute, which is pretty slow, but that's what we're required. As we start to get load, we're going to slowly increase our engine speed to overcome the resistance of the hose that we have laid out. So right now we're running about 2 pounds of inlet pressure and 55 pounds outlet pressure, and we're hitting right at 1,100 gallons a minute. A little more resistance, we give it a little more speed. Speeds up our hydrostat, our force feeder, also speeds up our engine speed. So now that he's got flow at the tractor, we've met the resistance of the distributor, and now we need to start overcoming that. So we'll slowly throttle the engine up till we get to the desired flow rate that we want. 25 RPM at a time is what we have set. And then we'll let things normalize. We could also come in here and turn this pump into auto throttle by setting a purge and a target speed, and our pump will automatically adjust the force feed percentage of how much power gets put to the submersible pump and how much engine speed we need to be throwing to make sure that we stay at 1,100 gallons a minute. With the pressures of auto throttle, we can make sure that we stay below the desired outlet pressure. As you can see here, being we're on a really short set, we're not even running out of
where it's at. We'll just hang here for a little bit.
10-4. So as we're operating, as I'm simulating what's happening in the applicator tractor, I have the opportunity to glance over and see exactly how my pump's behaving. In this scenario, we have both the same pump pulled up in 2 positions. We can get rid of that very quickly. Change the view for everybody. And we notice as he's turning around, because we don't have a whole lot of flow in the 6-inch hose, we end up with a few restrictions that we got to overcome. So we're going to throttle that pump up just a little bit to get back to our 1,100 gallons per minute. Okay. While we're doing this, we can also check our hydrostat. We have good charge pressure, we have good hydraulic level, it's at 95 degrees and it's running about 2,000 psi. I get to see my inlet pressure, so if I need to make adjustments, so I need more inlet pressure, means I need to put more horsepower down to my force feed, I can increase the power to that force feed and bring that inlet pressure up right where I want it. Right now I think 7 pounds of pressure is good for this scenario and about 80 pounds of outlet for a lead pump. Normally what we would ask for is somewhere around 30 pounds of inlet on a booster pump. So at this point you can see that the system's pretty well normalized. We don't have to make a whole heck of a lot of adjustments to it, and at this point I'm going to be focusing on other operations as I'm setting maybe AB lines, or maybe messing with my rate controller, or maybe doing some additional documentation in between while I'm pulling the hose. I can just glance over and have the security of knowing that everything is online, everything is operational, everything's behaving as it's supposed to. And that means also that the rest of my crew can go on to laying out another set, running fuel, moving air compressor, and I've got the complete control of the line. As we mentioned earlier, we not necessarily need to get rid of all the four-wheelers and people at the pumps, but we need to streamline what they do so that they provide more value to our business. Having them stand around and having the risk of driving back and forth in accidents just to monitor pumps is something that we can inherit as a risk, but if we can eliminate it, that's one less thing we have to worry about.